Good morning, Physics 20. I hope you guys are all doing well today and you're ready to rock some physics, as always. So today, ladies and gentlemen, we're going on to our next part of circular motion, and we're going to be looking at centripetal force. So remember how last video we talked about centripetal acceleration? Well, this one is now centripetal force. Okay, remember centripetal means center-seeking, okay, in Latin. So the center-seeking force on any particular object that's spinning in a circle is going to be your centripetal force. Okay, so ladies and gentlemen, remember how we have our object moving in a circle. Well, the velocity, if the object is here, and remember your velocity is your tangent line, right? Our acceleration, there's our center, is going to be that way. Now remember from our dynamics unit about how the force and the acceleration are going to be going in that same direction. So when you've got your keys spinning in a circle, there are my keys. And once again, wrapping up the keys really good so don't bust anything. So when you're spinning an object in the circle, the force, okay, the centripetal force is going to be pulling inwards. Okay, so it's going to be pulling inwards, whereas that's where centripetal force is going, and the velocity is going to be going that way. Sounds good? All right. So, ladies and gentlemen, we just demonstrated exactly how we can get this. You can whirl an object on a string or keys on a lanyard, okay, and try not to hit yourself in the face. That has definitely happened in class before. Or, this is also important for those of you guys who are driving, the frictional force when a car is going to go around a curve. So, you know, on the highway when you're coming up on the road, kind of does something like that on the highway. There's your highway. There's your dots down the middle of the road. It'll probably be a solid line on a curve. Anyway, so notice, ladies and gentlemen, that when you have a speed limit on a curve, or slow down to this point in speed, there's actually a reason for that. We're going to mathematically show you why you should be slowing down on the curves when you're driving. Okay? No driving like a goon. All right? And why in the winter you need to slow down even more on the curves. So we'll talk about that with our practice problem. I think that's question number 3, okay, with our notes here. Okay. It could also be the force of gravity as the moon is going to orbit the Earth, which we're going to be looking at later. And it can be the force between an electron and a proton as the electron's spinning around that proton. So this is a very, very important lesson, ladies and gentlemen. The equations that we're looking at now are going to be haunting you on and off throughout the rest of this particular unit. And they're going to come back to haunt you again in Physics 30 next year. So this is a very important lesson. Some of the concepts I'm going to be teaching you are going to be coming back again and again and again. All right. So ladies and gentlemen, how we can calculate our centripetal acceleration. Now this bit is super important. Super, super, super important. It is utterly imperative that you guys remember this piece. We can derive these equations from Newton's second law. Now, these equations that we're going to put here are not on your data sheet, but are actually not too difficult to derive. Okay. So remember from your data sheet that we have our Newton's second law equation of F net over m. Okay. And that's our Newton's second law. We also know that, well, if our acceleration is the F net, well, if our F net happens to be our centripetal force, there we go. So ladies and gentlemen, this is okay because our FC, it is the sum of all of the center-seeking forces that happen to be acting on that set of keys. So we can use this. That's okay. All right. Well, if we rearrange this, our FC is going to equal MAC. You see where I'm going with this? Remember that AC equals 2 equations. v squared over r, or AC equals 4 pi squared r over period squared. These two equations are on your data sheet. You have these. Now remember how we can take this part of the equation and equate it to something here. Well, if AC is equal to v squared over r, I can replace that AC with the v squared over r. So FC equals m times v squared over r. Okay, so that is very important. Or what I could do, I can take this A and replace it with this. So that should be an equal sign. Or my FC is going to equal m times 4 pi squared r over t squared. All right, so I'm going to switch over to blue here because I can. These two equations here, ladies and gentlemen, are super important. We're going to be using these again and again and again and again throughout our video lessons. You're going to be using these again and again and again and again throughout your assignment. If you had an exam, these would be on your exam. So unit test, final, quiz, you name it. It's going to be on all of them. It's coming back next year. So I'd write these down on your data sheet. Wherever they're easy for you to find, so that way you know that they're there. And I'm just going to use these equations. I'm not going to derive them every time. I'm just going to use the equation. Okay, so I would write these down, have them available, so that way you can see them, and that way you don't have to derive it every time. Sounds good, guys? All right. So, ladies and gentlemen, let's scroll on. And ladies and gentlemen, graphing. You guys excited? Yeah, you're excited. Important skill for next year, guys. Very important. All right, so for this one, FC and V. So, ladies and gentlemen, I'm trying to compare these guys here. So I need to make sure my equation is rearranged so that this is set up so y is going to be similar to our y equals mx plus b. Okay, let's go back to our usual red ink here. Okay, so by setting this up so we have y all by itself. Okay, well, I know that my FC is going to equal my mv squared over r. Okay, well, ladies and gentlemen, I'm going to compare these here. Now, this equation is the one that I picked. Now, why did I pick this? It's of the two equations, it's the only that we just derived. It's the only one here that has these two values in it. Well, fortunately for us, this derived equation is already set up in such a fashion that the FC is on the y. Okay, so that's exactly what we want. Well, now I'm going to take these guys out, and I'm going to make it proportionate. Whoopsie, I got rid of that m. Shoot. There we go. So the force, centripetal, is going to be proportionate to v squared. All right. So, ladies and gentlemen, well, this is similar to our y is going to equal x squared. So think back to those graphs patterns I told you guys to memorize on our last video, and that means our general pattern is going to look like this. It's going to be exponential. So, ladies and gentlemen, once again, important for Physics 30 next year. All right, FC and T. Well, ladies and gentlemen, of the two equations we just derived, the only one that has period in it is our FC is equal to our m 4 pi squared r divided by the period squared. So, fortunately for us, will you look at that? The FC is already on its own, just the way we want it to be, with our y-axis being isolated here. So this is our y on our y-axis, and now I can compare it to everything else. I'm going to equate everything else here to 1, and I'm going to then make it proportionate. So our FC is proportionate to 1 over t squared. Well, ladies and gentlemen, this is very similar to y is equal to 1 over x squared. What happens when we see that? Yep, like that. And of course, your drawing is going to be much neater than mine. And that is going to be the graph pattern you're going to see for that one. Once again, you compared it to the graphs I had you guys memorize last day. Or if you didn't memorize them, the ones you just put a sticky on in your notes so you can come back to them as an easy reference. If you haven't put a sticky on that page already, do that. It's important. All right. Onwards and upwards. Next one. So, ladies and gentlemen, during the sport of hammer throw, it's an Olympic sport. It's actually pretty cool to watch. Yeah, all right, there we go. We've got a competitor holds onto a rope with a heavy mass attached at one end, and that is called the hammer. The competitor spins around and releases the hammer, and then how far you throw the hammer is how you get your points. A competitor spins around 5 times in 9.7 seconds. If the mass of the hammer is 12 kilograms, okay, let's write that one down. That's an easy one. And the distance from the competitor from the mass end is 1.65 meters. Okay, the distance from the competitor on the mass on the end. So that's the length of the rope, essentially. So, ladies and gentlemen, what is that? Radius. As if this is the pattern in which the hammer is being spun, and here is the guy in the middle who is holding out the hammer, and here is the length of the rope. That's your hammer. Okay? And then as the guy spins in a circle, that, ladies and gentlemen, okay, so that's your radius. All right? Okay. So our radius is 1.65 meters. All right. Well, now the next thing we need to do is we need to do something with this 5 times in 9.7 seconds. Well, 1, 2, 3, 4, 5, 9.7 seconds. Well, what is actually useful to us? Period. Period is useful. What is the definition of period? The number of seconds it takes to do 1 revolution. Well, in order to get the period, I'm going to take my 9.7 seconds, I'm going to divide that by 5 because the competitor went around 5 times. So, ladies and gentlemen, what this is going to give us for our period is 1.94 seconds. So it took this competitor 1.94 seconds to do 1 rotation. Sounds good? Cool. All right. So we have these values here now. And what is the tension on the rope? Now, when we're going to be dealing with your force centripetal, your tension is equal to your FC. Now, because we have period and we have tension, I'm going to write tension as 10. So our tension is equal to our centripetal force. So if you are ever asked a question about what's the tension on the rope when an object is spinning a circle, tension is going to equal your centripetal force. Sounds good? All right. Okay. So, ladies and gentlemen, I'm going to erase this circle because it's taking away from my calculation space. All right. So, because our centripetal force is equal to our tension. Now, remember the equations that we just derived. Remember that FC is equal to MAC. You go to your data sheet and you can find your AC. And I can take my AC, which is my 4 pi squared r over period. I'm going to take that, plonk it in there. You don't have to show your work in that manner. You don't have to show me your work of deriving it every time. You are more than welcome to simply just write out your new equation of m4 pi squared r over the period. Okay, well, plonk my numbers in. The mass is 12 times 4 pi squared. Now remember, ladies and gentlemen, I do not want to see 3.14 is pi, okay? What I want to see for pi is this guy here, okay? Now, how do you get that little symbol in your equation? All you do is you go and you click a little blue second, and then you're going to hit the exponent hat over here, okay? And that's going to give you pi. That is as many digits as the calculator will handle, okay? And it'll give you all the digits of pi that the calculator can handle, okay? Because remember, pi is infinite. All right. So, ladies and gentlemen, now our radius of our lovely value of 1.65 meters. All right, and then we divide that. Now I dropped the squared on my period. That is not cool. Put that squared back there. Okay, now I can take my 1.94 and square it. For whatever reason, I've got a thing about forgetting to square time. I have no idea why. Okay, time or period. Okay, so ladies and gentlemen, plonk this all into your calculator. Make sure it's in there properly. And once you have your answer, 2.769 dot, 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 well, I need sig digs. So I come up here, well, there's 3, 3, 3, 5 times is not for sig digs, okay? You don't use that. And okay, we're good, 3 sig digs. Now I'm gonna round. So ladies and gentlemen, that 9 rounds up that 6 rounds up the 7. So we're going to have our FC is going to be 208 newtons. And ladies and gentlemen, I said, what is the tension? I asked for what the centripetal force is. That means I want towards the center, or center seeking, or something along those lines for your direction. Cool beans? Cool beans. If I say what is the magnitude of the tension, do I care about the direction? No, I don't. All right, ladies and gentlemen, as promised, here is the question where I'm going to lecture you guys about driving appropriately on a curve on the highway and the physics behind why you do not need to drive like a goon. All right, no goonery. All right, so we have a mass of a 925 kilogram car. Now, ladies and gentlemen, note the word car. This is not a question about a pickup truck. Your pickup trucks, my pickup truck, they're going to weigh a heck of a lot more than your 925 kilograms. So what we can actually do is we can look at the speed. The mass actually isn't going to make a difference in this question. It's just the speed. But the mass of your pickup truck, remember what we were talking about earlier, it may not change our centripetal motion here, and I'll show you why in a minute. But, ladies and gentlemen, what is it going to change? Your stopping distance. So, ladies and gentlemen, for those of us who drive pickup trucks, slow down earlier, especially when mu is low. And when is mu low? When roads are icy or wet. Okay? So, ladies and gentlemen, then we have got the mass of the car and on an unbanked curve. Now, those are the type of curves that we are going to be looking at. So that means the road is flat. That's an unbanked curve. If we were to have a banked curve, now most curves on the highway, especially like the really big highways like the QE2, the curves there are often banked, okay? They're banked at an angle, okay? Now, I'm not going to be giving you guys equations based on this. However, tan theta on a banked curve for this question equals mu. So that is something that that's how they are going to be able to calculate the speed limit for these types of scenarios. They would take in order to find the angle that they need to build the highway, they would use tan theta. Okay, so yeah, that's kind of cool. I think you guys would enjoy that. So as you guys are all starting to get your driver's licenses or have your driver's licenses. So, ladies and gentlemen, I'm going to draw this a little bit. So you've got a curve. There's your road. There's your car. Now remember, your momentum, your velocity, is all going that way. And your centripetal force is pulling you in. Now, ladies and gentlemen, what is preventing a skid? Force of friction. Okay. Now remember, your force of friction is going to be acting in opposition to your other forces. So FC is pulling you this way. Force of friction, ladies and gentlemen, is pulling you that way. Okay. So it's also pulling you this way too, but for our purposes, we're worried about this force of friction while we're on a curve. Okay. So what is the minimum coefficient of friction between the car and the road to ensure the car doesn't skid? Okay. So we want to find mu. Okay. We're not worrying about that one there. Okay. So, and your car is driving at 25 meters per second. Okay. So our force of friction is going to equal our FC. Ladies and gentlemen, that is going to be our principle. In this question, ladies and gentlemen, I'm going to go about equating equations. You don't have to for this one. You are more than welcome to calculate your FC and then make it equal FF and then do the math in multiple steps. But this is going to become an important skill for later on in the unit. And this is going to become an important skill in Physics 30. So I'm only going to equate equations for this method, okay, for this time. So, ladies and gentlemen, I have these values. Now remember, force of friction is equal to mu Fn. Okay. Fc is equal to MAC. Okay. Remember from all of our other previous dynamic stuff, unless the car is accelerating up or down and we are not the Jetsons. Do you guys remember that cartoon? That like really old cartoon with flying cars? Yeah. Silly show. Mu mg times m. Now I'm going to expand. Well, I have speed. So that because I have speed, I have to use the v squared over r. Now, ladies and gentlemen, look what I have here. Let's switch to blue. I have a mass here. I have a mass here. The mass is 925 kilograms for both cases. I am going to cancel out the mass. What's significant about this, ladies and gentlemen, is that this is why we don't have speed limit differences for the size of your car when you're going around curves. Because whether you're driving, the old Civic I was driving back when I was in university, loved that car. It was so much fun. Standard transmission, it was great. Like crank windows, manual locks, no AC. Standard transmission, no, ton of fun to drive. Or the F-150 I'm driving now, the speed limit I have to drive around the curve to avoid skidding is going to be the same. Okay, that's why we all have one speed limit. Need it? Okay, but what's the difference between a car and the big truck? Stopping distance. Okay, so, and as we'll talk about next year, your momentum. We'll talk a lot about momentum next year. Whole first unit next year in Physics 30. So, ladies and gentlemen, my mu, whoopsie, should be writing back in red again. There we go. So my mu times g is now going to equal v squared over r. Well, I'm trying to find g, so I need to try to find g. We have g. I'm trying to find mu, so I'm going to get rid of g. I'm going to divide g out on both sides, and I'm going to cancel g there. So my mu is equal to v squared over rg. Okay, so ladies and gentlemen, I'm going to plunk my numbers into my calculator, into my equation. So my 25 meters per second squared, don't forget to square things, okay, and then over r, so our radius, 72 meters, that's a 7. And you're going to multiply it by g, which is, as always, 9.81. Plonk your numbers into your calculator. Now, ladies and gentlemen, this is important. When doing this, 25 squared, enter. Divide by bracket 72 times 9.81 bracket, enter. Okay, because if you go 25 squared divided by 72 times 9.81 all in one go, your calculator will think 25 squared, divide that by 72, calculate an answer for that, and then times it by 9.81. So put this into your calculator carefully. Remember, it's 25 squared, enter, divided by bracket 72 times 9.81 bracket. Cool beans? All right. So ladies and gentlemen, our mu is going to be 0.88468 ... And our mu is going to be 0.885, unitless, no units, because I want 3 sig digs. Okay, so ladies and gentlemen, well, let's think. I want to mess around a little bit here, spontaneously with with math, to show you about how speed limits are calculated for curves. Now, this or what radius they're going to need to decide on. So, let's say they're fixed on a radius. Okay, now here's your road, and let's say, I don't know, it's a major highway. Let's say the radius is going to be, let's say 80 meters. Why not, right? Well, what speed limit are we going to do? Okay, so you can, if we're going to be banking the curve, okay, well, you can get what your mu is because tan theta is going to be mu. Well, if they need to know the angle to bank the curve, they can do the math that we did up there and then go tan -1 to get your theta. Okay, so then they would need to know what angle they would need to put the road at. Well, now we've got our radius of 80 meters. Okay, we know what mu is. Well, what's our speed limit going to be? Well, how fast can you actually go? Well, with that, the same thing, your FF is going to equal your FC. And then we can, just like we did up above, our mu mg is then going to equal our mv squared over r. We cancel m just like we did previously. Our mu g is going to equal our v squared over r. Well, I'm going to multiply r over, okay, and then I'm left with v squared equals rug, and then I square root that. So ladies and gentlemen, your speed limit is determined by square rooting the radius, and if it's a banked curve, you'd use tan theta to get your mu times g. So that, ladies and gentlemen, is how you would determine the speed limit. Now, ladies and gentlemen, let's think for a moment here. That is the minimum speed. Oh, sorry, the maximum speed you can go without skidding. Now, is that actually the speed limit? No. Have you guys ever sped while driving? We all have done it. I've done it. I think I've got one speeding ticket in my life. Totally my fault. I was being an idiot. I was driving 120 in a 100 zone on the May long weekend. That's really asking for it. So tip for life, guys. If you ever get a speeding ticket, the best way to handle it is be polite. You were speeding. Don't try and be rude to the officer. Be polite. So when the officer pulls you over, you wait in your car with your license and registration. And when the officer comes to the window, you say, "Good morning, officer. How are you today?" Right? And then the officer will say, "Good, thank you. License and registration, please." You give the officer your license and registration. And then be amiable and be polite with the officer. And when he says, "Do you know how fast you were going?" What I did is like, "Yep, I'm sorry, officer. I was going 120 in a 100 zone. My fault. I should know better." And then had an amiable chat about the officer. I had fish blood all over my shirt. I was fishing that morning. And, explained that, yeah, I was fishing. And he said, "Okay, I'm going to give you 10 over instead of 20 over. So he saved me like $80 on the ticket. So I still had a speeding ticket to pay. But he gave me a break because I was polite and reasonable. So the second you go in there and you get all boo-hooey and sob and tear, don't do that. Okay, don't turn on the waterworks because you got a speeding ticket. I know that's not cool. Don't get mad and angry and yell. You do either of those things, you're very, very likely to get not get your ticket reduced. Okay? And besides, and even if you don't get the ticket reduced, what harm is going to be polite being to the police officer? None whatsoever. All right? They're humans too, and you never know. They may have had a rough day dealing with other people who are being rude while speeding. You may as well make their day good. All right? Ladies and gentlemen, have a good day. Don't drive like a goon. Do your practice problems. No fires, injuries, or explosions. No burnouts. And here are some practice problems for you guys to work on. And hope you guys have a good day. No fires, injuries, or explosions. Now I can't turn this off. Stop button, where are you? Have a good day, guys.